Okay, so this is for Statistics MA 215, Chapter 5, question number 3, or quiz number 3, question number 6. So we're talking about an ESP experiment. Subjects must predict whether the number is randomly generated by a computer and whether it will be even or odd. So computer puts out an integer number and the subject has to guess whether it's even or odd. So the first question we always have to ask ourselves is, what distribution are we talking about? That's the big question. And so the one distribution we know about is the binomial. And when do we use the binomial? So the three conditions for binomial is, number one, it's fixed number of trials. All right, fixed number of trials. Number two is that trials are both independent and identical. So that's number two. And number three is the success or failure. Okay, so I have fixed number of trials. Trials are both independent and identical, and there's success or failure. Well, in this case, the computer is going to randomly generate either even or odd. So the person either guesses it correctly or they don't guess it correctly. And the fixed number, 36 to start. So that we're going to use the binomial distribution because all three of those conditions are met. Okay, so part A. It asks for what is the probability that a subject would guess exactly 18. So exactly 18 correctly. Okay, so for exactly we use the binom, and then we're going to use the PDF because that's exactly. And there was 36 trials, that's n, and the probability is a half or 0.5 because odd or even, there's 50% chance it's odd, 50% chance it's even. And then exactly 18. So I'll type that in my calculator. For the second part, it asks what is the probability the subject would guess more than 20 correct in a series of 36 trials. So part B is more than 20. So remember that more than 20, we have to be careful about something. Binom CDF is n comma p comma r is something that we use for r less than or equal to a number. And in this particular case, it's talking about more than. This is a key word, more than. Okay, so let's write this all out. So the probability of 0 guessed correctly plus the probability of 1 guessed correctly plus the probability of 2 guessed correctly, skipping ahead, the probability of 20 guessed correctly plus the probability of 21 guessed correctly plus plus the probability of 36, right? So all of them guessed correctly. All of that's equal 1. So you add up all the possible probabilities and it equals 1. That's what makes it a distribution. So then I'm going to draw a little box around more than 20. So this is more than 20. So more than 20. Don't count 20 because it doesn't say 20 or more. This is more than 20, so don't add 20 in because it says more than 20. Doesn't say 20 or more than 20. And then if I solve for this box, what do I get? Well, let's be careful here. I've got this red box, and inside that red box I've got probability of 21 plus ... plus the probability of 36. I've got all those, and that's equal to 1, and then minus all of the things over here in this gray box, because I had the 1 that comes from my distribution of the probabilities all equaling 1, and then subtracting, I'm going to move all the things in this gray box over to the other side of the equation. So that's all going to go down here in this gray box. And what goes there? Well, the probability of 0 plus the probability of 1 plus ... I skipped the probability of 2, but it's the same idea. ... probability of 20. And that's going to go inside this gray box. So, in order to figure out the probability of more than, all I need to do is calculate what's on. And what is that? Well, that's 1 minus the binom CDF of 36.5 and then 20. So once again, this is 1 from that one, minus from that minus, and then the binom CDF of 36.5 and 20 is what this means, right? So I'm adding up 20 and 19 and 18, 17, 16, blah, 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 down to 1, down to 0. I'm adding those all up, and that's what happens when I use the CDF. So I type this in my calculator. I do 1 minus binom CDF, and I do 36 and 0.5 and 20 with commas in between, 36 and 0.5 and 20, and I hit enter, and that's equal to 0.2025. Okay, I hope this helps. Let me know if you have any more questions.